This is the queuing model where M is the Markovian Poisson arrivals and second M represents the Markovian exponential service times. 1 indicates a single server, N indicates a limited system capacity, that means maximum number of customers allowed including one being served. FIFO means first in first out service rule. So this is M by M by 1, N by FIFO, the finite capacity queue. Basically one can see traffic intensity, formula will be rho is equals to lambda by mu. It means how busy the system is. It compares the arrival rate to the service rate, where arrival rate is lambda and service rate is mu. One can observe that suppose rho less than 1, then the system is stable. If rho is equals to 1, the system is fully utilized. If rho more than 1, the system is overloaded, that means infinite queue is not allowed here, since what you have the capacity is finite, that means capital N is finite. Probability of 0 customers, its symbolic expression P0, it is the formula. It means that the probability that the system is completely empty. You can see the probability of n customers in the system under steady state conditions. Pn is the notation. The formula will be P suffix n is equals to rho power n P naught for n is equals to 0, 1, 2 up to capital N is the capacity. It means the probability of having exactly n customers in the system. We have blocking probability P suffix n. The formula will be P suffix capital N is rho power capital N into P naught. It means the probability that a new arrival is blocked because the system is full, where the capacity is capital N. You have the formula for effective arrival rate, that is most important parameter. It means rate at which the customers actually enter and get service and get served. That means those are not blocked. Lambda is lambda into 1 minus Pn, where Pn is the blocking probability, or you can use the second formula mu into 1 minus P naught. So generally how many arrivals you have, based on that we have a departures. In this context effective arrival rate is computed. Average number in the system LS, it is the formula. It means that average number of customers in the whole system, that means those are in the queue as well as those are in the service. We have average number in the queue, LQ is the notation. We have the formula. It means average number of customers waiting in the queue. So here one can observe that excluding the one being served is most important one. Average waiting time in the system, WS, it is the formula. It means that average time a customer spends in the system, that means waiting time plus service time. So it is waiting plus service time, generally average waiting time in the system. You have average waiting time in the queue, WQ is the notation. You have a LQ by lambda E as per the Little's law, or you have this one. So it indicates average time a customer spends just waiting in the queue, it is only the average waiting time in the queue. You have another one, the probability of no wait, that means the probability that an arriving customer does not have to wait. So that is the only the probability of no wait, and its formula probability of no wait is P0 plus P1. You have probability of waiting, and its formula probability of wait is 1 minus P0 plus P1, or you have probability of wait in terms of effective arrival rate, and lambda is probability of wait is lambda E by lambda. It means probability that an arriving customer has to wait in the queue, that is only the probability of waiting. You have probability of direct access into the system, that means q free entry, the formula will be probability of direct access is the summation index n vary from 0 to k minus 1 pn. Here you have some threshold where small k is less than the capacity capital N. It means the probability that an arriving customer finds less than k customers and they can join without delay. So that indicates probability of direct access into the system. Again, you have a probability of empty system. So it is another way to compute the same as in the point 2. So it is a alternative formula. So you have a Little's law. So that is used for used as a verification tool. It is a formula. So it is a Little's law. Ls is lambda e ws, lq is lambda e wq, where ls the number of customers in the system, lambda e is effective arrival rate, ws is and the waiting time in the system, lq is the number of customers in the queue, lambda e is effective arrival rate, wq is the waiting time in the queue. So it is used to check the consistency of the results, and one can observe that these formulae a fundamental law in the queuing theory.